Hey guys, welcome to class. Today we're doing lesson 6.4. We're going to talk about similar and congruent figures. So we first need to start off with a couple definitions. The first one is similar figures, which are two figures that have the same shape but not necessarily the same size. Same shape but not necessarily the same size. So take just a minute and write that down in your notes. The second definition is for corresponding parts, which are sides or angles that have the same relative position. And we'll talk about that more in depth in just a few minutes. So go ahead and write that definition down now. Now there's also a couple important symbols that we're going to use quite a bit, and these symbols are really important to us when we're working with the shapes because they communicate something to us, so we need to use them carefully. The first symbol is for congruence, and we're actually going to talk more about congruence in just a few minutes, but the symbol for congruence is an equal sign with a squiggly line on top of it. The second symbol is for similar, which we just defined as two figures that have the same shape but not necessarily the same size. And the symbol for that is just that squiggly line. When we're talking about a line segment, we always identify a line segment by the 2 points that are the end points of it. So if we were talking about the line segment from point A to point B, we would label that as A, B, and then we put a line on top of it to indicate that it's a line segment. The next one is for an angle, which that's the symbol that we use for an angle. And the last one is for a triangle. It's a pretty obvious symbol. It's just a triangle. Now, if you look down at the next box, it talks about the properties of similar figures. And we're going to start off our lesson today talking about similar figures. When we know that two figures are similar, as we do here in this example, and you can see here it tells us that triangle ABC and triangle DEF are similar. And we know that because we see that symbol there. That means that they are the same shape, but not necessarily the same size. And we can see from the two figures that they most definitely are not the same size here. One is much smaller than the other one. But when they're similar, there's a couple things that we know about them. The first is that their corresponding angles are congruent, or in other words, they are equal. That means the angles that are in the same relative position. So notice here A and D are in the same relative position, so they are equal angles. And B and E are in the same relative position. They're in the top right. Same with C and F. They're in the top left of the triangle. Same relative position, so they are corresponding. We can also actually use this statement over here to help us see which angles are going to correspond, because the first letter listed in the first triangle corresponds to the first letter listed in the second triangle. And the second letter listed in the first one corresponds with the second letter in the second one. And the third letter corresponds to the third letter. And that's going to help us, especially when our triangles are not necessarily facing the same way, or the way we say that is they don't have the same orientation. The other thing that we know is true about similar figures is that the ratios of their corresponding sides are equal. In other words here, we can see that AC corresponds to DF. And so if we were to write that as a ratio, we would say it is 4/8. Well, we always write ratios in simplest form, and we know that would simplify to 1/2. We could similarly say that AB corresponds to DF. And if we were to write that as a ratio, we would see it's the ratio of 5/10, which also simplifies to 1/2. And similarly, we could say that BC and EF correspond, and therefore if we were to write that ratio, it would be 3/6, which also simplifies to 1/2. So the side lengths are not equal, but the ratio of the side lengths are equal. All right, so here's our first example. It says, given that triangle XYZ is similar to triangle UVW, name the corresponding angles and the corresponding sides. Now, the first thing that we need to do before we can name the corresponding angles and corresponding sides is we need to make sure that these two triangles have what we call the same orientation. In other words, meaning that they are going to face the same way. So, we're going to pick one triangle to leave alone, and we're going to rotate or flip the other triangle. So I'm going to go ahead and leave the XYZ as it is, and I'm going to redraw the UVW triangle to face the same way. And I'm going to go ahead and cross this off so that I don't get confused. Now, how do I know which letter goes at which vertices? Well, remember we can go back to looking here. The first letter of the first triangle is in the same corresponding position as the first letter of the second triangle. So there's X, which means right down there needs to be U. Same thing with the second one. Y and V need to be in the same spot. So if there's Y, then down there is where V needs to be, which means Z and W need to be in the same spot. Now, once you've redrawn that triangle, that's honestly the hardest part of this problem. So now we're ready to list the corresponding angles and sides. When we list angles and sides, it is super, super important that we use the correct symbols as well as match those correct letters. So the first pair is that angle X and angle U correspond. We can also say that angle Y and angle V correspond, and last angle Z and angle W correspond. It is very, very important that you use that angle symbol. It's also important that you match up the correct corresponding ones. It doesn't matter which pair you list first. If you listed that angle Z and angle W corresponded first, and then X and U, and then Y and V, that would be just fine. Now we're going to list corresponding sides. This is just a bit trickier. So the first pair I'm going to say is X, Y, and U, V. So side length X, Y, and side length U, V. We can also say that XZ corresponds with UW. Make sure you put that line to show that it's a line segment. So XZ and UW. And the last pair is YZ and VW correspond. Just for clarity, hopefully you see that this side length here I can call either XZ or ZX. It's the same side length, so it doesn't matter. Now I'd love for you to try example 1. Start by redrawing the quadrilateral so that it matches up with the same orientation as the other shape. It doesn't matter which one you redraw and which one you keep, but you need to do that first. Then list the corresponding angles and sides. I'll give you the answer in just about a minute. All right, so go ahead and check your answer with mine. There's a couple things you'll notice. First, you'll notice that I redrew my figure. How did I know what letter went in each corner? Well, I looked back up here and I knew that S and W needed to be in the same corresponding location, and T and X, and U and Y, and V and Z. And then from there, I listed the corresponding sides and angles. Notice that I used the correct symbol, angle sign, and line segment symbol. The other thing that's important to note is you do have to match the correct pairs, but you might not have listed the pairs in the same order as I did. For example, I listed ST and WZ, and then I listed SV and WZ, and you might have flip-flopped that, and maybe you listed TU and XY next, and that's okay. Or maybe instead of calling this TU, you called it UT. As long as you have the correct sides matched up, you're just fine. All right, the next thing we're going to do is we're going to find ratios of corresponding sides. We've already talked about corresponding sides. We've already identified corresponding sides. Now we're going to write the ratio. To do that, we're going to write the ratio comparing the lengths of a pair of corresponding sides. Then we'll substitute the side lengths in and simplify. Let me give you an example. We know that AB corresponds to QR. So I can write the ratio. AB corresponds to QR. The length of AB is 9.6. The length of QR is 12. Now I need to simplify that. Remember in that discussion problem where we talked about how we wanted to get rid of the decimal. So I would first multiply both the top and the bottom here by 10 to get 96 over 120. And there you can simplify. This actually simplifies down to 4 over 5. Now, if you remember back on the first page, we talked about how corresponding sides, their ratios are equal when we're looking at similar figures. And these two figures are similar, and therefore we need to prove that their ratios are equivalent. And so for each of these problems, you should find the ratio of at least 2 sides. You can do all 4 sides, but 2 sides is going to be enough, and it does not matter which pair of sides you pick. So for my next pair, I'm going to pick AD and QT. So I know that AD corresponds to QT. AD is 8, QT is 10. Again, I want to simplify that, and you'll notice it simplifies to 4 over 5, therefore proving that 4 over 5 is the ratio of these corresponding side lengths. Here's 2 more similar figures. Now, luckily for you, in the previous example, as well as in this example, the shapes already have the same orientation. In other words, F already matches up in the same corresponding location as K, and G and L, and H and M, and J and N. So we don't need to flip or rotate anything, which saves us a step. Let's write one pair of corresponding sides. We could say that FG corresponds to KL. FG is 8, KL is 6. When I simplify that, I get 4 over 3. So I'm pretty sure that's my ratio, but I'm going to use another pair of sides to prove it. One other thing that I didn't point out in the previous example that is incredibly important is, remember, when we deal with ratios, the order matters. This tells us to go from shape F, G, H, J to KLMN. So you must list this shape first or on top and this shape second or on bottom. All right, let's try another pair. It does not matter which pair you pick. I'm going to pick that GH corresponds to LM. GH is 16, LM is 12. I can divide the top and bottom by 4, and again I get 4/3. Therefore proving that my ratio is 4/3. All right, let's go ahead and fill in the blanks here at the top of the next page. Two figures are congruent if they have the same size and the same shape. Notice this is different than similar figures that had the same shape but not necessarily the same size. Congruent figures have the same shape and the same size. Therefore, they're essentially the same. If two figures are congruent, then we know that the corresponding angles the corresponding angles are congruent, meaning they are the same, and the corresponding sides are congruent. In other words, if the shape is the same size and the same shape, then the angles are equal and the sides are equal. Congruent figures are also similar. All right, so it tells me that DEFG is congruent to KLMN, and I know it's congruent because of that symbol right there. And then it asks me to find the indicated measure. So the first thing it wants to know is how long is the side length KL? Well, I first need to, just like before when we were dealing with similar figures, redraw so that they have the same orientation. And again, I'm going to use the letters to help me match up. So D and K need to be in the same spot. And so since D is in the bottom left, I'm going to put K in the bottom left. And E and L need to be in the same spot. So if E's in the top left, I will put L in the top left. And F and M, so if F's in the top right, I will put M there. And that leaves N down in the bottom right corner. Now it's going to be much easier for me to name corresponding sides. I know that the side length KL corresponds to DE, and therefore must be the same as DE. So I'm going to say that KL is congruent to line segment DE. So KL has to equal DE, and therefore must equal 8 feet. Don't forget your label. We can also do the same when we're talking about angle measurements. So angle L is congruent to angle E. They are in the same corresponding or relative position, which means the measure of angle L has to equal the measure of angle E. Just a quick side note there, when it has that M in front of the angle sign, that means the measure of angle L instead of just angle L. Since angle E is 111 degrees, I know the measure of angle L must also be 111 degrees. All right, so the directions here tell us that EFGH is congruent to PQRS, and it wants us to find the indicated measures. So again, the first thing I'm going to do is redraw one shape to have the same orientation as the other. So I'm going to redraw the second one. E and P must be in the same spot. F and Q need to be in the same spot. G and R need to be in the same spot. And H and S. And then I need to also copy down the other side links because I'm going to need those. So PQ in the picture was 15 centimeters, and angle Q was 126 degrees. That's going to be helpful and important to us. So here's how we show our work. If we want to find the measure of angle P, we need to identify what angle P is equal to. So I'm going to say the measure of angle P is going to equal the measure of angle E, because those are the corresponding angles, and so the measure of angle P would be 98 degrees. You need to show what it corresponds to, because that's how you know what it is equal to. The measure of angle F corresponds with the measure of angle Q, and therefore the measure of angle F would also be the same as the measure of angle Q, which is 126 degrees. You can do the same thing for side lengths. So side length RQ corresponds with side length the GF. So since side length GF is 8 centimeters, I know that side length RQ must also equal 8 centimeters. And the last one, side length EF corresponds to side length PQ. And therefore, since these are congruent shapes, I know that the corresponding sides are the same. So side length EF equals the same thing as PQ, which is 15 centimeters. Don't forget that label. And there's our lesson on similar and congruent figures.